Welcome to the viewers. Now we discuss the convergence and divergence of infinite series. At first, we introduced with a sequence. Let suppose an be a sequence of real number then we may write it as by our notation a1 plus a2 up to an infinite number of terms that is sum of n equals to 1 to up to infinity an or sum of an. Both have the same notation used, and this will be called an infinite series. And this infinite series of real constants. Now if we are considering the finite level, suppose if Sn we denote it as sum of r is equal to 1 to up to n, ar taking notation as a1 plus a2 plus up to an, which is called the sequence of partial sums of the series sum of n is equal to 1 to up to infinity an. It is obvious because if we are taking that will go, if we are considering this series a1 to up to n up to infinite extent, and if we are breaking it down in this partial format, we are writing Sn like this a1 to up to an, which is a partial, not total, and total is infinite. So here also infinite, so it is partial sum of this. This is the overall concept of partial and is finite series. And now we are going to discuss the convergence of infinite series. Let's watch. Now an infinite series is said to be convergent if actually the convergence means this limit exists. If we take as limit n tending to infinity Sn, and if it exists, and that will be existence means limit as n tending to infinity Sn, it will be a finite real number in S. That is, say S, whatever may be the real number is, say S. And then we write as S is equal to sum of n is equal to 1 to up to infinity an. This is our criteria, and to prove this is convergent, that means our criteria is the existence of the limit at first, then it will converge a sum of limiting value. That is, this is the value. It is clear. Now let's take an example to clear the idea. Let's watch. Summation 1 by r is equal to r into r plus 1. Actually, summation runs r equals to 1 to up to n. And if we take it in this manner, write it as 1.2 plus 1 into 2.3 plus 1 into 3.4 in this way, plus 1 into n dot n plus 1 plus up to infinity. That is going on. And now we have to check it, its convergency, and it's clear. In this way it will be partial sum. It's not total, but at an infinite extent we don't know what will it happen, but we have to check it, either it is convergent or divergent. Let's watch. Now let us consider its partial sum. So let us consider Sn as a partial sum. That means 1.2, 2.3, 1 by 3.4 in this way up to 1 by n dot n plus 1, and it will reduces to, it is 1 minus 1 by 2, 1 means 1 by 1, plus 1 by 2 minus 1 by 3 up to 1 by 3 minus 1 by 4, plus it's going to 1 by n minus 1 by n plus 1 in this way. And if we omitting these brackets, all terms cancelled. Already we find we left these two terms, 1, all are cancelled, 1 minus 1 by n plus 1. Now taking this partial sum Sn, and if we take it as Sn as n tends to infinity Sn, what will happen? Now limit as n tending to infinity Sn, and that will be cleared, that it will 1, because this term already 0. So the series converges. And its sum is 1. We are finding that sum is 1. So in this way we can prove this. We end our discussion today, and in next my videos I discuss many topics of the series, especially for the convergence or divergence. Keep it watching. If you like this video, like it, share it. Don't forget to subscribe the channel. Thank you.